Okay, let's have a short look at the viscosities of non-Newton fluids. In the lecture before, I have introduced you to viscosity behavior of Newtonian fluids. I explained you a Newtonian fluid is when the gradient has a linear dependence compared to the shear stress inside the fluid, and this linear factor is the viscosity. That's a good explanation. And now if we have a short look at non-Newtonian fluids, this will change. We will not have linear dependency between velocity gradients and shear stresses inside the fluid. Okay, so that's what I told you. We have the shear stress, we have the gradient, the velocity gradient in the fluid, and there is no direct dependency between these two values if we have a non-Newton fluid. These fluids are positive. Here we have again our shear stress, we have our velocity gradient inside the fluid, and if we have a linear behavior and a linear dependency between those, we have a Newton fluid. We can also have a Bingham fluid where we have a distance here. We need an introductional shear stress. How can I describe? I want to give you an example. If we have, for example, a bottle of water. We have a bottle of water. It's filled with water, and what happens if the bottle is open? I turn it around. What happens? The water comes outside the bottle because I have a special viscosity of the water and just flows out. That's behavior of a Newtonian fluid. But what is, for example, a Bingham fluid? A Bingham fluid can, for example, can be ketchup, for example. What happens if you have a bottle of ketchup? If you have a bottle filled with ketchup and you turn it around, what happens? Nothing happens. The ketchup will not flow out of the bottle. You need to push on the top of the bottle. You have to introduce some shear stresses, and then the ketchup will come outside of the bottle. Okay, that's the explanation of Bingham fluids. You have to introduce some shear stresses into the fluid, and then it can flow like a Newtonian fluid. Otherwise, if you do not introduce any shear stresses, it will never flow like a Newtonian fluid. Okay, so here's also some simulation of non-Newtonian fluid. I don't want to stress it too much, this topic. I don't want to do too many calculations with non-Newtonian fluids. It's a really, you can imagine, it's an interesting topic, it's a complicated topic, but I don't want to do too much about this topic yet. But here are some simulations. I had an industrial project for fluid flow of non-Newtonian fluids, and here you can see some CFD simulations, but we don't want to do it here in detail. Okay, now we come to the end. I want to teach you something about the surface.